I just want to make a quick short video today about why 7 kilowatts isn't necessarily 7 kilowatts when it comes to the badging and the naming of these heat pumps. Now, I've just pulled together a few specs online to just demonstrate something to you. So in this video, I just want to quickly cover how heat pumps are labelled and badged, the difference between the input energy and output energy and which one they're actually labelling, modulation ratios and why that's important to understand, and then show you my real world example. So these are 4 popular monoblock heat pumps. So that means that the water is transferred from outside of the building to the inside of the building. There are split ones, but anyway, most people are going to have monoblock heat pumps installed in their house. These are just 4 very popular ones: Vaillant, Mitsubishi, Samsung and Daikin. And on here, I'll use my cursor. You can see what they're labelled at. So the one that I've actually got, and this is the reason I've picked it, mine is a Vaillant Arotherm 7 kilowatts. And you can see that actually it can output 10 kilowatts when it's 2 degrees outside and you're using a 35-degree flow. So it reduces its output as it gets colder outside. Of course, it's harder for it to generate so much output, and it's also a higher flow temperature is harder for it to generate. So it's rated for 7 kilowatts, but importantly, that's at -5 degrees outside and a 55-degree flow temperature, which is almost unheard of. I mean, maybe you'd see that when you're doing your hot water cycle, for example. And interestingly, on the spec sheet, the maximum input, which is the electricity that it can consume, is 3.45 kilowatts. Now, I've never seen that. I've never seen close to that. I went and scrolled back through loads of information just in preparation for this video, loads of my data. I've never seen it get that high, even when it was that kind of -5 degrees and it was getting up to hot water temperature. So I don't know why mine has never actually reached that electrical consumption figure, but most of the time it's nowhere near that, as I'll show in the next few slides. Anyway, I'm getting ahead of myself. The Mitsubishi EcoDan, they label it slightly differently. Theirs is the 8 kilowatts, which is actually rated as 8.2 kilowatts. And from the spec sheet, they rate at their outside temperature of -7 degrees, but at a lower flow temperature at 35 degrees C. And you can see that their maximum input is pretty similar to Vaillant, but they actually show what their electrical consumption is at which rated temperatures, which I couldn't easily find with Vaillant. I'm sure it might be hidden in some obscure back of 500-page technical document or something, but I was digging fairly deep to find these figures. It was difficult enough as it is, and it can show you that there's no level playing field. Samsung, once again, theirs is rated at 8 kilowatts, but compare the difference between the EcoDan and the Samsung. The Samsung is going for a lower ambient air temperature, a warmer ambient air temperature, but a higher flow temperature. So it's hard to get a level playing field between these various different heat pumps. The Daikins are very popular. Their 9 kilowatt is rated at 7 degrees outside and a 45-degree flow. So same flow temperature as Samsung, great, but their outside temperature at 7 degrees compared to -2 degrees. So this is not really showing a level playing field. Actually, most of these 4 heat pumps have quite a close crossover, and it shows that you could be forgiven for looking at the 9 kilowatt and thinking that's a more powerful unit, but very quickly we've seen that the Vaillant, which is the lowest labelled badged unit, can actually output 10 kilowatts at a quite reasonable heating temperature, and 2 degrees outside, that's fairly cold for us here in the south of the UK, and 35-degree flow, that's not extreme at all. A lot of systems will be able to adequately heat home 35-degree flow when it's 2 degrees outside. Anyway, I've waffled on far too long, but you can also see the maximum input electrical consumption. There is, here we've got a level playing field. We've got a bit of parity between the Mitsubishi and the Samsung, but interestingly, although they're both 8 kilowatts, the Samsung claims that the maximum electrical consumption is 2.67, whereas Mitsubishi claimed 3.51. Same ambient air temperature, same flow temperature. What is going on there? I don't know. Someone much smarter than me need to comment. Anyway, let's move forward. So just a quick point that it's not just the kilowatt output. This is the heat output that's going into the home. This is the electrical input that's going into the heat pump. They vary a lot between the heat pumps, but also between the temperatures. Like you could be looking at 7 or 10 kilowatts. That's a difference of 3 kilowatts. Some homes only need 3 kilowatts of heat input. But also the coefficient of performance and the sound pressure level vary just as much depending on at which temperatures they are measured. And that should be more clear to people, because once again, there's not a level playing field in how all of these devices are rated. Some of them, for example, the sound pressure level, the figures that they give are with the air temperature outside at 7 degrees and the water temperature, the flow temperature at 55 degrees. But not all of them give that rating. And the coefficient of performance, again, it is all over the board. Some of them are pushing figures at 35 degree flow, some of them are pushing figures at 45 degree flow. So you have to look at the detail, because there is no standardization here. This is just an example. Vaillant, for this part of it, their data sheet, really easy, really accessible for a layman to get their head around, and you don't have to look very far to find this information. This is mine highlighted in the red box, a 7 kilowatt unit, and at the top here you can see the flow temperature. So I know that my system is designed for a 45 degree flow when it's -2 outside. So I know, roughly speaking, I'm in this area. My unit will output somewhere between 8.4 and 9.1 kilowatts when I'm at my design temperature, design flow temperature, etc., etc. And I should be achieving a COP of 3.91. Now, in reality, most of the time, my flow temperature is 35 degrees or lower, because most of the time I don't spend heat in my house at -2 degrees. So even at 2 degrees, if my flow temperature is 35 degrees or below, then my output is actually 10 kilowatts. And this is one of the things that's causing actually the excessive cycling on my system, because my heat loss is about 6 kilowatts. Most of the kind of rule of thumb will tell you, oh, you need to add 10 or 15% extra capacity. So a lot of the installers will bump you up to a 7 kilowatt pump if you've got a 6 kilowatt heat loss, when in fact, actually, a 5 kilowatt heat pump, even at -5 degrees, it still would just about be perfect for my heat loss. Now, bearing in mind that my heat loss is just below 6 kilowatts, my design temperature is 45 degree flow, you can see that I would have been absolutely fine with a 5 kilowatt heat pump. But unfortunately, a lot of installers don't want to push the boundaries so far, and they want to give themselves a bigger margin of error, I guess. So it's kind of pre-programmed in to look at these headline figures. But as you can see, the 5 kilowatt heat pump comfortably outputs 7 kilowatts, even at a 45 degree flow temperature, even though it's badged as 5. And once again, it doesn't even show on here the lowest heat output is 5.4, even if you're at -5 degrees and a 55 degree flow. So the 5 kilowatt Vaillant Arotherm Plus is more powerful than some of the other heat pumps by the competition that are badged as a level above. It's all very frustrating. And then if you dig a little bit further into a lot of the technical details, it looks like the 3.5 and the 5 kilowatt unit are essentially the same unit in a lot of hardware terms, but it looks like they maybe have different programming or different algorithms or work slightly differently. But it's interesting that they do show a difference in the spec sheet here. Anyway, let's move forward. So minimum output is something to really get your head around, because we looked at some scary figures, and this is one thing that people get in a heat pump, or people who don't know anything about heat pump are very skeptical. A lot of electricians that might be in other parts of their trade but not understanding heat pumps, they go, wow, you're getting a 7 kilowatt heat pump, that's going to be running all day long, that's going to cost you an arm and a leg, it's going to use so much electricity. But what they're not understanding properly is that this is the maximum input, so they're never going to use 7 kilowatts of electricity, and this is the maximum. But what is the real world usage? For me, here we go. Modulation ratios aren't published in the technical documents. If you really dive into some of the tech sheets, then it looks like most of them are about a 4:1 modulation ratio. I did, at least for my own Vaillant Arotherm Plus, I did really delve in to find that detail, looking at the kind of minimum electrical consumption compared to the output, but it's difficult. It doesn't show that. Newer boilers are now starting to publicize that as people get more into low temperature heating. They want a boiler that does a 8:1 modulation ratio, or some of the good ones that do a 10:1 modulation ratio. But heat pumps at the moment about a 4:1, which still delivers like your minimum output could be somewhere like 2 kilowatts, which is one of the top end boilers will output something like 1.92 kilowatts in heat anyway. So there's still kind of a level, a comparable thing there. So anyway, here I'm showing now the minimum output assumption, and that's just based on dividing the heat output by 4. So I'm just assuming that all of them have a 4:1 modulation ratio. So you can see that they can all output this 1.75 to 2.25 kilowatts of heat into the home as the minimum, because most of the time they won't be operating flat out at maximum because it's not that cold in the UK all the time. What I should have put here is then the potential minimum output, because you could also divide these by 4 and you should get some figures of what the minimum output would be. But let me show you my actual data. This one, importantly as well, heat pumps don't run 24/7, and this here shows that for mine, although the controls are set to leave it running, this is the total energy consumption of my whole house. So this isn't just a trace for the heat pump, but it shows that my compressor kicks in, and when it fires up, it has a short burst, and these peaks are generally around 800 watts on this day in question, where the ambient temperature was anywhere between 5 and 8 degrees. So just a very typical mild-ish winter's day, nothing extreme. And then you can see after the compressor has kicked in, quickly settles down to between 500 to 600 watts, and that is kind of where it runs at. And on this particular day, it cycled on for 20 to 30 minutes, then off for the 45 minutes to an hour, and it did that throughout the day. So you can see how there's fears of a 7 kilowatt appliance running 24/7. That's going to cost me a fortune. But the reality is so far removed from that. Because of the cycling, it's not running all the time. Because it's a lot of the time, especially for mine, because the heat pump's oversized, it's running at its minimum modulation rate pretty much all the time. And because we also rate these systems for cold sustained weather, at those -2, 3, 4 degrees sustained periods for 48, 72 hours. We don't have that for most of our winters. We might have that once or twice throughout the winter period. But anyway, the conclusion here is that the market needs some standardization. As you saw from my very first slide, it is all over the place with how Mitsubishi, Daikin, Samsung, Vaillant, just to name a handful, are rating and marketing and labeling their appliances, and it makes it very difficult for enthusiast homeowners to understand different quotes from different installers. But even speaking to some of the installers, they're struggling to get their head around it. They know a certain brand, or some of them might know 2 brands very well, and they know how they compare. But across the whole market, there's no easy way to compare it. It's not like they have all been dynoed and they're all expressing the brake horsepower of a vehicle in the same way and showing certain figures along with that headline kilowatt output. And it needs to be made clear that the rating on the appliance is the heat output that's generated by the unit. It's not the input, it's not the electrical energy, because that's what we are familiar with. That's what we're used to. Okay, our kettle's 3 kilowatts. Our microwave is 900 watts or whatever. And we know that that is the electricity that it's consuming. It's not necessarily, we're not necessarily thinking about it as the electrical transfer, the energy being transferred. And then a final one is potentially as things as the market matures and these appliances, these heat pumps become more developed, potentially they'll improve the modulation ratio, or they will be producing smaller pumps. Because as you can quickly see, I'm in a a detached 4-bed house. It's not a mansion, it's not tiny, it's just kind of an average size, 140 square meters, if that means anything to you for reference out there. But our heat pump is also the middle of the range Vaillant. It has two below it, but actually the difference in output between the ones below it and above it, they're not actually huge steps. It's just kind of 1 kilowatt, 2 kilowatt. It's just, small little steps, when really there's a lot of properties. And even just messing around on heat punk and doing some DIY heat loss calculations that are really easy for anyone to do if you've got a technical mind and you understand a bit about building fabric. If you've done some extreme DIY like I have and cut your home open several times, you'll understand the build up of the walls and the makeup and the fabric of your building. You'll be able to do that really easily. But very quickly, I'm recognizing that most homes need small heat pumps, and there's a very small handful that need these 10, 12, 16 kilowatt heat pumps. Some of them do, in fairness, but there's a huge majority that need those 3, 5, 4 kilowatt heat pumps. And it would be really helpful if in the future smaller pumps are produced and better modulation ratios as well, because then something like a 7 kilowatt is excellent for hot water production, because it's got the bigger volume of the physical unit is bigger than the 5 kilowatt. It's taller, it's got bigger condenser, evaporator, and it's got a bigger pump as well, so it can do better hot water performance, but it's not necessarily the most efficient when it comes to the central heating side of things. And the modulation ratio could fix that, because you could be running it flat out when you want really good hot water production, but then it would turn itself down much more. And I don't understand all of the engineering and the technical physics that go into it. I've had a little look around, and I understand a lot of the basics and how it works, but it seems to me like it's not a difficult engineering challenge for them to go the next step further and start having heat pumps that modulate at a 6-to-1, an 8-to-1 ratio. But anyway, I'm totally waffling on now. I just wanted to bring a video out that just shows you that 7 kilowatts is not 7 kilowatts, and 9 kilowatts isn't necessarily 9 kilowatts. So if you're watching this and you're in the middle of your heat pump journey, getting a heat pump, the first thing to say is trust a decent installer, because they will understand these things. They'll understand the different ratings. They'll be in the tech sheets. They'll be familiar with it, and they will be sizing one accordingly. So don't panic and don't question your installer too much. Maybe you need to if your installer's not so fluent with these things, but once again, there are things to mitigate this as well. Like for us, the oversizing of the heat pump is not totally the end of the world because of our buffer tank. That kind of helps with the oversizing a little bit, and I think that's one of the reasons why a lot of installers are quite comfortable with buffer tanks, because they know it's more likely that the system's going to work even if it is slightly oversized or whatever. It's going to literally give that buffer. Anyway, thanks for watching this video. I hope there's been something helpful. Press the like button, share it with someone. Definitely put a comment down below. What's your experience? What heat pump have you got? What size is it? What's your heat loss? Let's share some. The community is really building and helping people understand these things and opening up why it's important that we get our head around some of these things, and that the manufacturers don't have to treat all consumers like absolute idiots. The technical data sheets, I should have probably dragged this into frame here. This one is Vaillant, and it's really brilliant, and it's easy to find your way around it. The EcoDan ones are just shocking, just like terrible data sheets, terrible manuals. It's definitely more designed at the kind of big commercial end. Daikin, I found a similar sort of trend, difficult to find some technical details and to find some of the information, and the same with Samsung. But I guess the kind of difference there is Vaillant comes from a domestic heating background of doing a lot of that, and Samsung and Mitsubishi and Vaillant and Daikin, have been doing commercial air-to-air heating for a very, very long time. And so maybe they're starting from a different position, and maybe those things will improve as they become maybe a little bit more consumer focused, with a lot more of these going into residential homes. Stop waffling, stop the video, bye.